Okay guys, in the previous video I gave you a brief overview about the problem and I've explained to you what's the client-server communication and how things work. Now the problem occurs, and here I'm gonna get you a little bit more deeper about the problem, when we basically want to be more mobile and we download some application which requires an access to our resource. Right, so we have application right here on that mobile phone, and this mobile phone wants to access our resources since we want to be mobile and basically we want to use our phone in while moving and to have like access to our emails while we are moving. So now since this working perfectly, this scheme right here, I'm gonna remove the PC, and besides that I'm gonna basically replace it with a user, a simple user, right? So a user is basically giving a password to the phone to the third-party app, the third-party app use that password, authenticates to the server, then gets the resources, brings it back by the reverse way, and everything's alright, okay? But basically the problem is when we give our password, because let's take for example, we are talking about Google. Google have a lot of applications inside. It has applications for Drive, where we store files. It has applications for photos, when we store pictures. It has applications for calendar, which is used to store events. Applications for emails, for documents, and just so on. So one Google account represents multiple applications. So by having a Google account, you can use any single of these applications on your own, right? So if you give your credentials to a third-party app, this third-party app can use the credentials not only for gaining your resources, but to use other resources you do not grant permission to. And that's the tricky part, and that's was the problem. So this third-party app is developed by developers, which in most cases are a third party. And what I mean by third party, I mean that they are not designed and developed from Google in that example, because we're talking about Google accounts. So everything which is not made from Google is counted as a third party. So this app is developed by a third party, and if we store the credentials there, any credential is going to get stored to a database, and that database is not a Google's database, it's that developer's database. So our records, our information is going to get stored to database, so these guys going to have access to all of our files and resources anytime they want. So since we don't want to basically depend on their mercy and good spirit, we want to think for a solution for that problem. Because as I said, following this scheme, this application is going to have access to your resources, but it can have access to other resources that we don't want to. Let's take for example, this is Google Drive server, and using the same credentials, the third-party application can download, extract, modify, add files from our Google Drive, which is something that we do not want. So this is the problem. We don't want to give the password to anyone. And now let's talk a little bit about the solution. So the solution requires adding another component, and this component is basically an OAuth server. So this server is only used for authentication. So we have all the figures on the table. We have a user, we have a third-party application right here, we have OAuth server, we have resource server, and we have the resources right here. So we as a user, the main goal is to access the resources throughout this application right here, which is developed by a third party. So in the previous scheme, the user grants the password and the application is using the password for authentication and gathering information. But here, the application is not directly connecting to the server as it is here. As you can see, it's directly connecting to the server, but instead it's connecting to the OAuth server. So it's saying, hey, I want to access the resources of that user. And the OAuth server basically steps there and stops the process and says, let me ask the user itself. So it's prompting us with a login prompt right here. So this is the point when the OAuth server is requiring the credentials from us. But as you can see, the credentials are not required from the third-party application, are not directly acquired here, but are transmitted through the OAuth server. So the server is basically holding our credentials, not the application. So this point is basically when you, just show you for example, click continue with Google, with Facebook and so on. By clicking that button, as you can see, I'm prompted out with some credentials right here. Yeah, here, see, I'm prompted out with the Facebook credentials. So here right now I am basically right here on that specific point. I am prompted out with the credentials for the OAuth server. And if you take a closer look, we have an API login, we have an API key, which we're gonna talk about in the future videos. We have an ID. So this is the, now we are contacting with the OAuth server. As you can see, it's on Facebook, so everything is all right. Now, since we are prompted with the credentials, we enter the credentials and bring it back to the OAuth server. So now the OAuth server, which is held by the same company, in that case Facebook, or if you are talking for that example, it's held by Google. So we bring the credentials to the OAuth server, and the OAuth server is sending to the third-party application, it's sending a ticket. So as you can see, the third-party app do not have any access or idea who we are and the password of the user. It just sent a ticket, so it received that ticket. The ticket is basically information contains of letters and numbers combined randomly, but the good thing about our server is that it keeps any ticket into database and keeps track of it. You know that the machine do not have problem about calculating some things, and they do not worry if the ticket is long or if it has numbers and letters. They are just randomly generated, and OAuth server keeps them in a database, and that database contains of their expire time, their owner who owns that ticket, and their usage when and where. So everything is being tracked, which is the very nice thing about OAuth server. And if the ticket expires, because any ticket have expire time, if that time expires, the ticket is automatically removed in most of the cases, because if not removing the ticket can cause security flaws. So now the third-party application has a ticket, and its only choice is to request something from the resource server by sending that ticket. And here, that's all it does. It's requesting the resources from the resource server, but instead of the password, it's requesting a ticket from the OAuth server. So it says, hey, I want to access that resources, here is my ticket. And the resource server is, of course, not instantly accepting that ticket, is basically reversing and asking the OAuth server if that ticket is correct. So it's getting the ticket, is saying to the application, okay, wait a second, and it's asking the OAuth server by sending the ticket, and it's asking if the ticket is correct and if it's okay. So the OAuth server made a calculations right here, and basically if the ticket is valid and it's correct, it's comparing from the database. That's why it's storing everything to database, because the OAuth server is comparing the tickets from the resource server with the tickets of the database. And if the tickets basically are the same, they are held with the same user, they have the same expiry time and so on, the OAuth server says, okay, you can drain that resources. And so the resource server have access to the resources, drains the resources, sends back to the third-party application, and the third-party application sends it to the user, so we see on our phone. And the ticket stays there. So this is the solution. This is how OAuth is basically fixing that problem. Now the ticket is standing on the phone, and if we want to basically get more resources, we are opening a session with that server. And since that ticket is valid, we are just basically draining information from and on to that server. But as you can see, following this schema, nothing ever like a password, no password comes through the third-party application. Everything comes through that OAuth server. The OAuth server is held by the same company, and it's completely safe to store your password there. And the next thing that you need to remember is that the OAuth has a database which stores and tracks any ticket. So when the resource server is requesting and saying the ticket is asking for the validation of the ticket, the OAuth server just basically grabs that, compares it to a database, do a very simple calculation and says if the ticket is alright, if it is not. You may, for example, when you use this website, Facebook logins or Google logins, you can somehow encounter the expiry time and so on, and you need to refresh the whole procedure, and that's why your ticket has been expired. The validation has been slow, you have, for example, made that process slow and the ticket expires, so you need to refresh the process all over again. So you see, no password comes throughout this application right here. Everything is safe, and even the ticket has a time. So now the application does not know the password, cannot access directly the server, the resource of the server, cannot access your account and other resources contains your account. So now the application knows only what the OAuth server has permission to. So by modifying the permissions, we can say that I want to drain just that resource. Let's say I want to drain just the emails, nothing else, and that's how it's made. So by following this scheme, we are basically having access to only the emails or the resources that the server provides to us. So this is the solution that OAuth provides. In the future videos, I'm gonna explain about different components, how it works on the lower level, and how basically to connect your application with OAuth to make a secure connection.